looking at question 81 and 87. So 81, can someone just read it to me so we can just be there?
F of x equals e to negative x ln of x.
Like that?
The ln is just, it's times.
Ooh, no.
Yeah, like lower.
So it's like this?
No.
Oh, I see.
It's not an exponent.
Like that.
Yeah.
And then what was 87?
Ln of x to the fourth power.
All to the fourth or just to the
Yeah.
fourth?
All to the fourth.
All to the fourth. And y equals?
Yeah.
Okay, so looking at this one, we have a product. So I'm going to go green and blue, and I'm going to use the product rule. Do you see what I'm saying? Because it's a product, you have to use the product rule. So what's the derivative of the first? How do you take the derivative of e to the x? Derivative of e to the x is e to the x. Derivative of e to the negative x is?
Negative e to the x.
Yeah, it's e to the negative x times negative 1. But you take the derivative of the top, so it's negative e to the negative x. That's the derivative of the first. We got to multiply that by the second, so I'm just going to rewrite the second. Plus the derivative of the second. What's the derivative of ln of x? Yes? 1 over x. Now we have to multiply that by the first, which was simply e to the negative x. And that's the derivative, really. You could, of course, move it around a little bit, but that's basically what we're looking for right there. So don't forget the chain rule from that e to the x. Is that okay?
Yeah.
So maybe just you don't need to know it's a product rule. I think maybe some people didn't.
Yeah, I think I just didn't do that.
Yeah. So product rule and you'll be okay. 87, is it? ln of x all to the fourth. So what do you think you should do because you have something all to the fourth? So what do you do when you have something all to the fourth? Put the 4 in front and? Yeah, so dy dx, put the 4 in front and then leave it alone and then bring it to the third power, right? Agree? Now the chain rule. Times by what?
1 over x.
Yeah, so do the derivative of that and just multiply by it, 1 over x. That's it. Actually not as bad as you might think.
Wait, was 89 part of the 90? Was that, what was the numbers again? 70?
I think I went to 93 or something like that, or 95 or something. 73 to
Can we
93?
actually do one more?
Yeah, sure.
Either 89, 91, yeah, either 89.
89 or 91? 89? They're both hard because they have the log properties. So this is what I was trying to like whip through at the end of class. So I was whipping through it and I was like, yeah, remember log properties? Yeah. So that's where I was like hoping you would still be able to get these ones for the most part. So 89. And after that, it was like, forget it because we didn't really cover it. So I have to cover it today. So ln of x, square root of x squared minus 1. ln of x, square root of x squared minus 1. Like this. Now, when we look at this problem, there's a lot of ways to solve it, but what I'm telling you is that logs can be your friend. Whenever logs have two things multiplied together, I'm going to use the whiteboard here, ln of a times b, how can you make that into two different things? ln of,
A
yep,
times ln of b.
it's actually plus ln of b. That's the way logs work. So now let's make it into two. Instead of one hard one, we'll make it into two easy ones, easier ones. So what do you want to make it into?
ln of x,
I'm not doing any calculus, by the way. ln of x plus,
ln of square root of x squared times.
perfect. Oops, minus 1. So you see what I did? I made it into two easier problems, right? Well, now what I can do is I can actually take this and make it a little easier. Because if you think about it, isn't that also ln of x squared plus, minus 1 to the 1/2? So what does the property of logs say for that? Property of logs, remember that? So if you have ln of x to the 4th, let me just show you over here. This is an aside.
Oh, is it log 4?
ln of x to the 4th is equal to 4 ln of x. It's actually not calculus. That's pre-calculus. So ln of x to the 4th is the same as 4 ln of x.
So 1/2 ln of that is the same
Yep.
thing?
Yep.
Isn't that like finding the derivative?
Not yet. It's very similar to finding the derivative, but it is not finding the derivative.
So it's just changing around?
Yep, it's just changing around by normal algebra or pre-calc. No calculus has happened to this point. Technically, you should have been able to do this in the middle, like at the end of last year or at the end of like whatever, Miss Elk I think taught you a lot of it, right? So we reviewed it, I think. I just like did a crash course. She taught you much of this in the beginning. So now we have to do the derivative. We haven't done any calculus yet. So let's do the calculus. So what will dy dx be? So the derivative of y with respect to x is, so what's the derivative of ln of x? We'll just start with just ln of x. 1 over x, perfect. What's the derivative of this? Well, we'll leave the constant alone. What's the trick for ln? I was trying to tell you the trick for taking the derivatives of ln. Yes?
The derivative of the inside over the inside.
Perfect. So the derivative of the inside is 2x, right? And the inside is x squared minus 1. The 2's can cancel in that case, and you'll have 1 over x plus x over x squared plus, oops, sorry, I keep putting plus there. It's like the third time, minus 1. And that's your answer. That's your derivative.